Welcome back, everyone. Good to see you again. Well, in a virtual sort of way. Well, today we're going to take a look at some different ways, shapes, and forms of energy again. We've been talking a little bit about kinetic energy and potential energy, uh, but we find energy in all kinds of different shapes and forms, as we'll see. And that's going to be our focus for today as we investigate that a little bit. Um, some common forms of energy, you see mechanical energy is listed there, and that's going to include the kinetic energy and gravitational potential energy that we have been discussing. Tomorrow we're going to do a little lab which is going to incorporate those two things together, and as that's going to be a major key for us. But there are other kinds of energy as well. If you look at the diagram of thermal energy, now thermal energy is something that we have discussed earlier this year. We talk about temperature. Think of thermal having to do with heat. And we learned, I think, earlier this year that the faster things are moving, the faster the particles are moving, the hotter they are. All right, well, that's what thermal energy is. And thermal energy is an important currency in terms of energy that we use in a lot of different capacities. We've also talked a little bit about chemical energy, where chemical energy is stored inside those chemical bonds. And depending on how high energy those bonds are, when they are broken, they can release energy into the environment. That's why we use, gasoline and natural gas and so forth for burning things, because they have high energy chemical bonds. When those bonds are broken, they're going to give off some of that energy. We haven't talked much about electricity yet, but that's going to be a big theme coming up here in a couple weeks. But I think we have a little bit of a tendency, an idea of what electricity entails as we know about our positive and negative charges. You've seen lightning bolts, obviously. Hopefully you've never been shocked by a little spark from an outlet, but there's some real energy there. And obviously we count on it in our daily lives a ton. Well, in order to watch this video, you're on some device that is using electrical charges to power your device. When you walk in a room and you turn on the light switch, again, we're using electrical energy to change into, well, our next form of energy, electromagnetic energy, waves and light. And here we talked about the electromagnetic spectrum just last unit. All those different versions, depending on the wavelength and the frequency of the light or the wave, is going to determine what type of energy it is, whether it was radio waves, whether it was television waves, whether it was visible light waves or infrared, ultraviolet, X-rays, and so forth. And they're all different ways of transmitting energy from one place to another. And we also talked this year a little bit about nuclear energy. Inside that nucleus of the atom, we have that strong nuclear force is holding that nucleus together. But if that nucleus gets broken or added to, in the case of fusion, an enormous amount of energy can be released. Nuclear fission, if you recall, is when we would break apart the nucleus of the atom. That's what's used in our power plants and can be used in nuclear weapons. And nuclear fusion is what happens on the surface of the stars to power the stars. Looks like some people in here might need a little energy boost this morning. Now, one thing that we also have alluded to this year a little bit, but haven't spent a ton of time with, and that's what we call the law of conservation of energy. And like the law of conservation of mass that we discussed earlier, it has to do with things not being able to be created or destroyed. They come from somewhere and they go somewhere. Okay? One of the key important components of this, though, with energy is energy can and does change forms all the time. If you look at our diagram here, we got a sunshine going to a plant, which, of course, gets buried under the ground for millions of years, becomes oil and gasoline, and then can come out and get thrown into your motor and power a car. All right? All of those denote some different form of energy in the process. You think you can trace those together? Well, let's see what you came up with. Nuclear energy is happening, of course, like we mentioned, in the stars. That energy gets here via electromagnetic waves, electromagnetic energy, and gets stored inside plants, which is a form of chemical energy. And when that chemical energy gets broken and released, it turns into thermal energy. And that thermal energy inside the motor of a car makes pistons go up and down, causing the mechanical of the energy of the car then to move. We change that into a kinetic energy. So all those different forms, they play into each other, and there are different energy transformations that are happening all the time, going from one form to the next. Well, it's time now to hit the quick quiz and see if we can't put this all together. Tomorrow we'll do something a little different. We're going to have a lab. You will need a golf ball, some other bouncing form of ball. If you can find together a meter stick or a tape measure for tomorrow, and you'll want to work on some sort of hard surface like a sidewalk or something where the golf ball will bounce well. Until then, have a great day.